So let's solve some problem here. In the first problem, we have like time period of oscillation of pendulum is given by this equation, and we have to figure out this equation is the homogeneous equation. So let's do, what is pendulum, right? This is a pendulum. Pendulum is like, suppose this is your pendulum. uh, it swing forth and back. Okay, this is the, it goes the position from position A to B, position A to B, and back at position A again. Okay, this back at position A, and that this total time from here from A to B and back to A is called time period. For example, A to B and from B to again A. This is total time is called time period of the oscillation. Okay, we measure that time period of oscillation in second. Okay, let's do. What is T square? T square equals to here 4 pi A square L by G. L is the length of the pendulum. This is the here, and we have to solve that the left unit of the left hand side. This one, it must be equal to the unit in the right hand side. What is the unit in the left hand side? This is the time. Time we measure in second, right? This is second square, right? And what is the, this is the constant. We have no unit, so no unit. This one no unit, and this is length is measured in what? It's a meter, and G is the acceleration due to gravity. How we can measure it? Meter per second square, right? And this meter cancel, so it's gonna be 1 over second square, which is second square. So right hand side of the unit is equal to the left hand side, so this equation is homogeneous. Yes, this is the homogeneous equation. Okay, in you can test different equations by calculating the left unit in the left hand side and the unit in the right hand side. If they match, and we can say that this is the physics equations. Okay, in the next problem, like this is relatively new for you. uh, we are calculating the velocity of sound in air. What is velocity? Velocity is distance upon time, right? Okay, wavelength of the sound is 17 meter. And what is the how the wave look like? So this, for example, this is a wave, and wave is like it's traveling like this one. So many things. Okay, wave, and there is a half cycle. Half cycle. This is half cycle, and this is also the half cycle. And from this is from A to B, for example, this is called the full cycle. When you travel from the A to B wave, this is called the full cycle. And the distance it travel from the in one cycle is called wavelength. And the time it takes to travel from to one cycle is called time period. just okay. Okay, this is the one cycle complete, right? Time period. And what is frequency, right? Frequency is the number of cycle in 1 second. For example, this is 20. 20 means the sound travel the 20 cycles in 1 second. Okay, means t plus how many t? Up to 20t, right? It travel total time. First cycle is complete. That in 1 second. Total time is 1 second. This is 20. And so this is called frequency. Frequency equals to, we normally get frequency into time period. This equals to 1, and t equals to, how we calculate, 1 over frequency. Okay, we know the time. This is t using the frequency, and we also know the distance, wavelength. Wavelength is given here, 17 meter from here to A to B. So what is the solution here? Distance equals to 17 meter. At the same time, t equals to 1 over 20. And the velocity is how much? V equals to distance upon time. And V equals to, you can calculate, what is the distance? 17 divided 1 over 20, which is equals to 17 multiplied 20. So the velocity of the sound, B equals to 17,340 meter per second. Okay, this is the how you calculate the velocity of the sound if the frequency is given. The frequency in wavelength is given. Okay, if another problem, if frequency is 100 hertz, right? 100 hertz, and the velocity is same. So another problem, you can pause this video and solve this problem. Okay, what is the, if velocity is same, because that velocity is always same, but frequency, we change the frequency of the sound by 100 hertz. What is wavelength? Wavelength is bigger than 17. It's bigger than 17 or less than 17. You should find out. Okay. Thank you very much.